Okay, hello everyone. Welcome to our MIS class. Here's our week 4, actually our 4th session, and we're going to consider chapter 7 of our book, which is about telecommunication, the internet, and wireless technology. First of all, please let me know whether the voice is clear enough and you can hear me or not. Then we can start our lecture. Okay, good. Seems voice is good today. Okay, here is you can see our objectives for this chapter. Identify the principal components of telecommunication network and key networking technologies. Describe the main telecommunication transmission media and type of networks. Explain how the internet and internet technology work and how they support communication and e-business. Identify the principal technology and standard for wireless networking, communication, and internet access. And finally, we consider assessing the value to business of radio frequency identification, RFID, and wireless sensor networks. So first of all, we need to have a definition for computer network. What is computer network? Can you guys give me a definition for computer network? If you want to talk about it, I can pass you the mic before I am going to explain. Come on, guys, take your chance to speak in class. You're supposed to participate from this week. Okay, Mr. Naveed.
Hello, sir. Do you hear me?
Yes, I hear you.
The question is, what is a computer?
Computer network.
Computer network. First of all, before we know what is a computer network, we should know what is a computer. It's a machine, a complicated machine, a sophisticated machine, modern technology, which was firstly used by American military armed forces, and it's a kind of machine for computing mathematically and logically information for accurate and storage and so on, accuracy and storage and so on. But this kind of machine was also used for kind of easy transfer of information and data from one place to another place, connecting one machine to another machine, which was the start of the computer network. So in the recent technology, we see there are a lot of ways or systems for computer networks that voice is broken.
Okay.
That computers are connected we have an intranet, which is inside a kind of organization, a system intranet with we call it inside one organization in a kind of building, an office, and also internet, which is it is international communication, that is computers connected from one country to another country through cables and networks, and also other things that today we would learn, like I heard of like WAN, MAN, and so on. So there are different kinds of networks and so on. This much that I knew, I just shared, and
Okay,
I hope
thank
it
you,
was useful.
Mr. Navid.
You're welcome.
Yeah, but very simply we can say when two or more computer, or from an organizational point of view, two or more employee connected through the IT technology and through the computer devices, we call it as a computer network. So once we make this connection, we establish this connection between two computers or more than two computers, we already have our computer network. There are some major components in a computer network, in a simple computer network. We can name them as a client computer, software, a server computer, pardon me, a network interface or NIC or network card, connection medium, network operating system, hub or switch, and router. Here in this slide, you can see a simple computer network. They have some PCs, and they have their own NIC or network interface card, which by this NIC the computers connected to a switch, and this switch may connect it to the bigger one in the other layer switch, and we can have our server, and server also got NIC, and if we want to connect our network to the internet, we need to use the router. A very simple computer network illustrated here in this slide. But how about the larger companies and larger computer networks? Components can be included hundreds of local area network or LAN linked to firm-wide corporate network. Various powerful server, websites, corporate intranet, extranet, backend system, mobile wireless LAN or Wi-Fi networks, video conferencing system, telephone network, wireless telephone, Voiceover IP, all these are the components of a large computer network for a big companies, organization, or firms. As you can see here, the corporate network infrastructure. We have some sort of servers. Here you can see a wireless LAN. Here is our wired LAN. LAN means local area network. When we say local area network, it means this network is within one building. And a company may have different, as you saw in the previous slide, they may have hundreds of local WAN, and they connect all these networks together. Here they have mobile Wi-Fi network, and by using Internet Service Provider or ISP, our networks can be connected to the Internet. And in addition to all these systems, we can use the telephone system by using telephone service providers. And these days we use actually big companies, organizations use the internet telephony or voice over IP, like Skype, which is the most familiar one, and OVO is one of the newest IP telephony software. And in big company and big organization, they connect their offices in one city or in a different city in a country or in a different country through the IP telephony based on their established network infrastructure. Instead of paying to the telecommunication companies, they build their network, and based on their network they use the IP telephony. So we need to consider the key digital networking technologies. First of all, client-server computing. Client-server computing is a distributed computing model. Client or users link through network control by network server computer. Server sets rules of communication for network and provides every client with an address so others can find it on the network. So we have a server or some sort of servers and so many clients. That server sets some rules to manage these clients, and each client should have its own address based on the NIC that they use. They have a specific address. And client-server computing has largely replaced centralized mainframe computing. The Internet, largest implementation of client-server computing in the globe, we call it Internet. And the TCP/IP, connecting between computers enabled by some protocols. The TCP/IP protocol is the rules that govern transmission of information between 2 points. TCP/IP stands for Transmission Control Protocol, Internet Protocol, TCP/IP. It's a standard, it's a worldwide standard, is based for Internet. Remember I said each computer got a specific address. That address we call it as the IP address, Internet Protocol or IP address. That address set in each computer, it's like let's say different cities have so many houses, and in a country you may have hundreds of cities, and each got a postcode, and by that postal code you can find a specific house within a country. And TCP/IP or IP address is like this. Each computer in a network got an IP address, and TCP/IP is a standard, is a protocol to manage all these addresses and to help the computer to connect and transmit the information. And we have different sorts of protocols. The older version was OSI, It was based on 7 layers, but the newer one is the 4-layer establishment, application layer, transport layer, internet layer, and network interface layer. You can see this layer here in this slide, TCP/IP reference model. In computer A, we have this 4-layer. Also in computer B, we have same layer, and these two computers are going to be connected. So in the application layer, layer is the first layer that a user using. For example, we sit behind our computer and start from connecting to the internet, using and browsing internet, open our browser, bring some websites, go check our emails. Anything we do in our computer is in the application layer. So we as a user connect to the application layer. Then behind that is transport layer. Transport layer is responsible of transferring your data. They have a different protocol. For example, TCP, UDP are the two most famous protocols for transporting the information. And then in internet layer is the layer that the IP address checked for each computer. And then network interface is a physical layer, the information gathered from the application, then to transport, then to internet, and finally to the physical devices to send to the network through some cables or something, and then reach to the destination, which is computer B here in this case. In the target computer, in the destination, first physical layer involved, then internet, then transport, and finally application layer. So guys, you have my voice or not? One of your friends said no sound. Okay, it seems the voice is okay. Okay. So in a communication network, we need to differentiate between digital and analog signals. Modem, in computer we're using digital, but in a telephone establishment which already established and we use that one for connecting to the internet, the signal is analog. So we use modem. Modem stands for modulator and demodulator, translate digital signal into analog form or to the reverse. And the other thing is type of networks. Already talked about LANs. We said LAN is a small network which within a building. It can be client server, or can be peer-to-peer, and there is some standard topology. Topology refers to the way we connect, and the method we use to connect the computers into a network. It can be bus, star, and ring. CANs, WANs, and MANs are the other kind of networks, but in general we can say WAN or wide area networks is the networks that bigger than LAN, different LAN in city or in a country connect together and make a wide area network or WAN. So in general, we consider two types, LAN and WAN. And here in this slide, you can see the function of modem. Here, start from this computer, some digital code 0 and 1, and modem translate them to the analog one, and the destination computer, again another modem, transfer this analog to digital, and finally it's read by computer. Here is the network topologies, bus topology, star topology, and link topology. Bus usually used for backbone system, and the other system mostly use star topology. Like for example, they call it star, but when you maybe see a network, you cannot imagine it as a star network, because there is only a switch and the computers by some cable and RJ junction connected to that switch. This is a normal one that you may saw all around you in the companies and organizations. Mostly use the star topology. They have their own features, and any of these topology have their own features and characteristics. So in network communication, we also need to consider and have some information about physical transmission media. We have twisted wire, which used in a network. For example, the star one is the normal, network cable. You may know connected. You can check your modem, not the cable connect to the phone line. The other cables that connect the different computers and NIC card to the switch. We call that one as a twisted pair or twisted wire. The other one is coaxial. Coaxial cable is like the the traditional cable we use for antenna, TV antenna, and in the older system like bus, we use the coaxial cable. The most recent technology is fiber optic cables. It has very high speed and transfer a bigger amount of information. And there are some sort of wireless transmission media and devices, which is very common these days: microwave, satellite, cellular cell phone, and transmission speed considered based on hertz and bandwidth and these things. So, what is Internet? We already said Internet is the biggest establishment of networks, different hundreds, thousands, millions of client-server network connected to each other, make Internet for us. Wherever there is a telephone line, you can use that telephone line to connect to the Internet all around the world. But you need to get the service from Internet service provider for connecting to the Internet. And we also talk about the Internet addressing and architecture, IP address, the domain name system. Domain name system also a manager these days need to know and have some information about it. It's a sort of hierarchical structure, top level domain. You can see here in this slide. Start from root here. The top level domains are, for example, edu.com, .government.org, and .net. And in the lower level, second level domain, for example, we can have Expedia, Google, Congress, and in the third level we have some department of that company or that website, for example sales.google.com, and finally we can even have computer1.sales.google.com. It means this computer from the sales department of a Google company, which is a .com website from the root. This is the domain name system. So as you all know, we have different services based on the internet. You can use, for example, email, chatting and instant messaging, news group, telnet, FTP or file transfer protocol, World Wide Web, Voiceover IP, virtual private network. These are all the services we can use by using internet. In this illustration, you can see the client computers running a web browser and other software and access an array of services on server over the internet. These services may all run on a single server or on multiple specialized servers. Here you see there is three different sorts of servers: database server, application server, and another server for connecting to the internet and using the internet services, which connected to the web pages or mail files. And the user here, by using its computer, laptop, PDA, tablet, mobile phone, anything, connect to the internet and then connect to the different servers, and finally in a backend system we can reach to the database. HTTP is a protocol. These are different protocols. HTTP is a protocol for which bring the web pages for you. HTTP, if I'm not mistaken, stands for Hypertext Transfer Protocol. And SMTP for a protocol for mail, DNS, domain name system, FTP, file transfer protocol, and there's so many different protocols for using the internet. If you like to have more information about these protocols, you can go Googling and find so many information about these different protocols and their responsibilities. So www stands for World Wide Web. There is a challenging issue here. These days the companies are growing faster and faster, and so you need to based on they're growing and they go to the global economy, digital environment, so they use computer and internet more and more. And these days in organization, companies uses computer, internet is a common thing. So what do you think? There is a challenging issue, an ethical issue here. Should managers monitor employee email and internet usage? Why or why not? What do you think, guys? We're going to discuss, we have time maybe around 15 to 20 minutes. I want you all to participate and discuss this issue. If you have any experience in this as an employee or as a manager facing this problem, can you please get the mic and share your experience, your idea, your point of view with me and your friends? Mr. Kakar, and then Mr. or Mrs. Brishna Oria. Okay, Mr. Kakar. Okay, guys, one by one I will pass you the mic and you can share your point of view. Mr. Kakar, I cannot hear you. I don't know if the other friends can hear or not. There is no voice. Mr. Kakar?
Websites like Yahoo and some other websites.
Can you please, I can hear you now, but can you please speak louder?
Should I speak loudly? Can you hear me now?
Unfortunately, I cannot hear you. Okay, it's better now. Okay. No, it's okay. It's okay. It's better now.
I have turned off my mic. It's okay now?
Okay.
Okay. I just want to repeat what I said. That employee at official offices, they have two types of email addresses.
Okay.
One is the official email addresses that they always use for official activities. And that could be easily monitored by the managers, and employees don't have an issue or a problem with that. However, the person probably there could be an agreement between the employer and the employee on their time usage on the internet and also the email checking and other stuff.
I don't know. Your voice got problem. Let's pass the mic to another friend.
Hello?
Yes.
Do you
Can
hear me?
hear you. Yeah, Miss Krishna. Okay.
I think that the manager mentioned the employee email and identity. It depends on employee and manager, because in many offices and in many organizations, employees use the internet, for example, for chatting or Skype, not for official use. the person. In this case, it is okay to monitor their usage of the internet. And if the employee doing their work good, and I think it is not okay to check their email or monitor their email on internet use. Thank you.
Unfortunately, your voice is not very clear. Can you please repeat some of the main points you highlighted? Hello, Miss. Miss Oria, can you hear us?
Yeah, I think in some organizations and in some offices,
Yeah, I can hear you now.
okay. Is it okay? Hello?
Yes, we can hear you now. It seems better now. Can you please repeat your main points?
Yeah. I said that in some organizations it is okay to monitor the employees' email and internet usage because in some companies and organizations there are some staff and employees that they use the internet for their wasting the time.
You mean you
5%.
you mean you believe that the manager should monitor the employees or not?
Yeah.
Okay, unfortunately, your voice is not clear enough. The other friends, so many of you raised your hand at the first, but now I don't know if any one of you guys interested to talk. Please let me know. Let me know to pass the mic to you.
Hello, do you hear me?
Yes, Mr. Navi.
Yes.
Your
I
voice.
agree with most of colleagues.
Okay.
There should be in the office. There should be an official email and official usage of internet. But monitoring the staff, I don't think there is time for managers to monitor and keep an eye to the staff. But as ITs can monitor, inform the managers, but on the same thing, I do not want to agree continuation of this, and I would agree if the manager do not monitor, but to give them some free time as well for the usage of social media and in an unofficial time after works or during lunchtime. Like some people use Facebook and so on in the office. But in order to keep a good spirit of a good working environment for the staff, the manager should encourage the staff to use the official email instead of private in the official work. And I think if there is a specific, the job is clear for the staff from the manager, and the manager gives the direction to the staff, the
Okay.
staff will be busy with the full work, and they would not have time to do other things than the work. So with the complete monitoring, I do not agree. And as you said, also it is also not good for the environmental working environment in the office. And the employees might be demotivated or a little bit unhappy that they are monitored, and they might feel frustrated sometimes, and sometimes
So you believe
their activities will decrease because of this monitoring system.
okay, yeah, so you mean the
Yes.
monitoring result in
Yes, sir.
dissatisfaction of our employees, and you believe that there should be some restriction and limitation, but give some times to the information to the employees for do the social networking or email or some usage of internet, right? Hello, Mr. Navi. Some other friends, if you want to talk. Mr. Faisal, Mr. Ubaidullah, you write something for us, and if you want to talk. So most of you, I think, believing that monitoring the employees is not ethical and result in dissatisfaction. So official email is a solution, can be used, but my question is that the internet should be, the employees should be able to reach to internet during the whole working hours, or no, they should be restricted or limited, and as Mr. Navid said, in some specific time, for example, within their lunch time or after work, they should be able to connect to the internet. These days in developing and developed countries, the internet and social networking or email is the necessity, and it's very important for employees to be in touch with the other department or other buildings or other company, organization, supplier, I don't know, customers, and these things. So if we let them to have internet, should I monitor them or tell them do this, do that, do not this, do not that, or no? We should leave them freely using the internet, but we have to be sure about their performance and their productivity. A friend believes that they should be always connected, but believe they should use social networks out of his hours. There's so many comments from your friends in the chat window. You can refer to that one. But you know, guys, the social networking, maybe I don't know, in Afghanistan, do you have any filtering or something or not? But in some countries, it's filter. On the other hand, in some countries, it's a necessity of conducting and doing business these days. Many companies, almost all the companies, all the firms and organizations all around the world these days have their own social network page, and to connect the manager, employees, customer, and during the 24 hours of the 7 days of the week. Okay. So in Afghanistan, you also have some sort of filtering. In the UN system, there is some restriction, but they encourage staff to learn and use the education websites mostly after working hours. Okay, I brought this challenging issue to you to think about it, because I know you have some experience in this one. I also had some experience, as an employee or as a manager. We have different point of view toward this, using computer and internet and social networking during the working hours or after working hours. These are all challenging issue in the organizations these days. So let's continue our lecture with an illustration of voice over IP. This illustration tries to show us how the voice over IP, or in short VoIP, works. User here using its computer, and for voice over IP there need to be two gateways. We call this one gateway. It's look like a router or a switch, and through internet they connect to our network. These gateways connect to our network, and we can connect our telephone system, our central telephone system, to these gateways, or maybe we have some IP telephony. We can connect them to these gateways, and through this internet connection, through this network connection, we can send and receive voice. That's why we call it voice over IP, because when we say internet, it means IP. It means we use IP address. So we send voice through this IP address, through this internet, so we call it voice over IP. And this voice over IP become possible for us by using the gateways. Gateway is a device we connect it and establish it in our computer network. And the other technology is a virtual private network using the internet. This virtual private network is, like you, based on the internet, you provide some channel for your company, for your organization, which has different offices all around your country. For example, in different cities you have different branches, and you provide a VPN, virtual private network, to securely transfer the data and information between your offices, your computers in a network. And the World Wide Web here, or in short, sometimes we call it as a web. Again, you can see the different protocols here. HTML, hypertext markup language, is it's a programming language for coding the web and make it able to use the browser and web search and browse the web. HTTP is a transfer protocol, hypertext transfer protocol. It makes able the communication for transferring web pages. URLs, when we say URL, it means a website address. You can see an example of URL here. Web server, software for locating and maintaining web pages. And the other things and terminology you need to know about it is search engines. Search engine started in early 1990s with a very simple programming software with some very simple indexing type of work, and then gradually, little by little, it's developed and it's enhanced. So today, major source of internet advertising revenue via search engine marketing using complex algorithms and page ranking technology to locate the result. Google is the most famous search engine website, and here in this slide we try to show how Google works. As you can see here in this illustration, the Google search engine is continuously crawling the web, indexing the content of each page, calculating its popularity, and storing the pages so that it can respond quickly to user requests to see a page. The entire process takes about one half second. This process starts from here. User enter a query, and in the second step, Google Web servers receive this query, receive this request, and Google uses and establish 450,000 PCs linked together and connected to the internet to handle incoming requests and process the result. And then in the next step, Google this request using some indexing servers to find and index the information that is asked for. And the next step, some page rank software using to rank these different pages and choose a specific topic or some sort of word for each rank, for each page, and then after the summary of this text, the result delivered to user, for example, based on 10 in each page. This is how the Google and the search engine works. So they use some indexing page. There are so many computers and servers, find the information, index them, rank them, and then finally show the result to the user. And major web search engines these days, as I said, Google 60%, and this information is based on year 2010. Maybe now the Google parts may increase, and the Yahoo 7%, 17%, MSN 13%, AOL 4, Ask 2, and some other search engine altogether 4. No, they are not. Your friends ask, does Google store all the information from the international network and that help it respond? We cannot say they store all the information. They use some indexing and algorithm methods and have different, server distributed all around the world, and that server connect to other systems, and by some sort of indexing and some complex and complicated algorithms, they find the information immediately and arrange it and bring the result for the user. So in the global internet, we also need to know about the Web 2 and Web 3. Web 2 is the second generation of the web, which is an interactive web. Web 2 also we call it as an interactive web. Cloud computing, blogs, RSS, and wikis are the result of using Web 2. For example, when we say interactive, it means when, for example, consider it when you use social networking, you go type something, some status, or comment on some photos or some links, and when you type it and press the enter key, immediately you can see what you have typed in the screen. And this one we call it interactive one, because you yourself connect to the web and to the internet and to, for example, to the social network site. So this kind of interactivity is enabled by using the second generation of web, or maybe you can have blogs these days, or RSS or wikis, are the result of using Web 2. The other generation is Web 3, which is recently established. It's more concerned about increase the efficiency of search engines. We also call this web as a semantic web. Semantic means collaborative effort to add layer of meaning on top of the web to reduce the amount of human involvement in searching for and processing web information. It means that we try to make our machine help them in general they say machine understandable. Semantic web means machine understandable. We try to make the machine like human, help the machine to find the meaning and realize the meaning of what we are search. For example, if we search, let's say, Apple, the Google or the search engine may bring you some definition or some page about the apple as a fruit, or may bring some information about the Apple as a IT company, or even they may bring some information about Isaac Newton, the guy who by falling an apple find the gravity, and all these different information. But in Web3 and a semantic web, try to establish some new technology and some new methods that help the machine to understand which apple we are looking for. Guys, the web is the environment that you use for internet. It's a technology. And the other more modest view of future web is increasing cloud computing and SaaS service, actually computer, service computing, and this thing, ubiquitous connectivity between mobile and other access devices. You can see these days you can connect your mobile phone to your laptop, your tablet, all the electronic devices all around you can be connected and synchronized to each other. And make web a more seamless experience. The web, guys, you're asking about the web itself. Web, have you seen the spider web? It has different cells and different things. So imagine the internet. Imagine all the computers all around the world connected to each other with some sort of lines. Okay, it's if you look at it from out of the box or observe it from the up, it could be like a spider web. That's why from the in the first step they call it as a web. And you need to know about the intranet and extranet. I think we already defined this thing. Intranet is the internal network of an organization. For example, use existing network infrastructure with internet connectivity, standard software developed for the web. Create network application that can run on many types of computer protected by firewall. So internet concern about our internal computer network. And the extranet is when some external parties like supplier, like customer, like government agency, and these things try to connect to our internal network or intranet. We call that one as the extranet. As you can see here in this slide, allow authorized vendors and customers access to an internal intranet used for collaboration, also subject to some sort of firewall protection. And you may need to have some information about wireless devices like PDA, BlackBerry, smartphone, or cellular system. For example, competing standard for cellular system in United States, for example, is CDMA in most rest of the world is GSM. I think in Afghanistan you also use GSM technology for connecting your mobile phones, and you also have 3G or third generation networks. I think in Afghanistan you're already using 3G network. I don't know if I'm not mistaken. I think you start using 3G. And also these days we have 4G as well. For example, in Malaysia we can use 4G these days. 4G is much faster than 3G. You can have more bandwidth for transferring the big files using the internet on your mobile phone with highest speed. Three G is the third generation network actually of connecting devices in the web. These are some very, if you want to open all of these, maybe each of these got at least take 2 or 3 sessions. So we just bring them here for you to just heard about it here. If you're interested and you like to work on this one, you can go Googling, or you can refer to your book and find some more information about them. Or even you can choose it for your individual assignment and work on it. And there is some standards for wireless computer network and internet access, like Bluetooth, like Wi-Fi. For example, we have different set of standards for Wi-Fi. You can see here all these standards. These are very technical in computer networking, and we cannot go further in our class and discuss more and this about this terminology. Just gathered here for giving you some idea that this technology is being used these days. If you need to have more information, you can refer to your book, and your book also is not deeply and in detail talk about this technology, but you need to refer to some telecommunication books or computer networking books. For example, I don't know, you can reach to Cisco books or articles, or you can use the cisco.com website for giving you some information about the computer networks and devices and technologies. But here in this example, you can see a 802.11 wireless LAN. We have our wired network, and we use a router to connect to internet, and we can have our wireless network. But for that one, you need to add another device to our network, which is an access point. This access point sends a signal. Based on the access point, the radiation of this signal is predefined, and the computers or laptops within this area can connect to our network. So the wireless revolution, I bring an example of some new technology in this area. For example, the most prominent one is RFID, or radio frequency identification. RFID is emerging technology in the wireless environment, which has so many applications. For example, in transportation, in guys, you can hear me? Mr. Obeidullah said no voice. Okay. So RFID is an emerging technology. As I said, it has so many applications. For example, in supply chain management, you can check Googling. For example, Walmart using RFID, or Dell using RFID in their supply chain management system. RFID use the very tiny tag with embedded microchip containing data about an item and location, and also that tag can have an antenna. Tag transmit radio signal over short distances. This distance also based on the different kind of tag you can use it. The difference is different. And to special RFID readers, so you need to have a special reader which sends data over network to computer or processing. So we also have a backend system. So active RFID and passive RFID. Active RFID are the tags have batteries. The tag itself got battery. Data can be rewritten, range in hundreds of feet more expensive. These are features of active RFID, and the passive one range is shorter, also smaller, less expensive, powered by radio frequency energy. So the tags does not have any batteries. As I said, there are some common uses of RFID here. Automated toll collection, for example, tracking goods in supply chain management, and requires companies to have special hardware and software. As I said, for example, we need some special reader. Reduction in cost of tags, making RFID viable for many firms. And here in this slide, you can see how RFID works. There is a tag here. A microchip holds data, including an identification number. The rest of the tag is an antenna that transmits data to a reader. Our reader is here. The reader also has an antenna that constantly transmits. When it sends a tag, it wakes it up and process and get the information and send the information to the host computer or database or backend system, which processes the data from the tag that have been transmitted by the reader. So this technology is using a lot. Even in you can search about it, RFID using in public transportation, using in retailers and supply chain management system. Even these days in natural disaster, by connecting this technology to the other one here, wireless sensor network can be used in in natural disaster events by connecting this tag to some sensors. For example, in terms of early warning systems or these things. So wireless sensor network is another technology. Networks of hundreds of or thousands of interconnected wireless devices embedded into physical environment to provide measurement of many points over large spaces, used to monitor building security, detect hazardous substances in air, monitor environmental change, traffic, or military activity. Devices have built-in processing, storage, and radio frequency sensor and antennas, require low power, long-lasting batteries, and ability to endure in the field without maintenance. And the next slide, you can see a wireless sensor network. See different sensors established in some sort of network, then they connect to a computer, and this one can be connected to the internet, so it can be remotely monitored. The small circle here in this illustration represents lower level nodes, and the larger circle represents high-end nodes. Lower level nodes forward data to each other or to the higher level nodes, which transmit data more rapidly and speed up network performance. So these are two examples of RFID and wireless sensor network, two examples of using the new and emerging technology in businesses or in managing the environmental issue or real world problems. For example, for RFID is one of your topics for individual assignment. If you are interested, you can go and do some research about the RFID, for example, RFID in retail, RFID security, anything related to RFID, you can do research about it for your assignment, and I'm sure you will like it because it's a very interesting technology. It has some very specific features and characteristics. If you may be interested, and you can work on it as your research. So guys, these are all about telecommunication, internet, and wireless technology. Thank you very much for your attention to this session. And our next class will be on Tuesday. So don't forget, and please be noted, the next class is on Tuesday, 6th of November, and on 8th, instead of 8th, the class is on Tuesday, 6th. We do not have a class on 8th of November. Our next class is on Tuesday, 6th of November. About your group works, I already assigned you a case explained last session. I also emailed you the file. Am I right? You got the file. So each group got a case. You go Googling, find information about the case, about the company itself, and about the technology and information system method or strategy they use, and you get different information from different sources, and then you need to summarize and arrange this information, add your point of view, and I don't know, some discussion, some conclusion in form of an academic report, you prepare them first, and then based on that, you can provide and create some slides for your presentation. If you don't want to make a report, also can make a slide immediately. I don't know, it depends on you. But if you want to do a good job, it's better to do your research and get your information, then prepare a report, and based on that report, make some slides. Guys, all the cases I gave you is about IS. When a company use, I give you the case, your friend asked, our case is about IT infrastructure. So IT infrastructure for what? IT infrastructure for that specific company. So if a company using an IT for conducting its business, it means IS, and it means Management Information System. Am I right? This is the definition we had from our first session. If we use IT in an organization to conduct our business, it means IS. We have our information system and managing information system. Yeah, it's exactly the specific in IS. IS means what? So your case is Hong Kong's new vertical communication prosper with a new IT infrastructure. So this company, for improving their business and enhancing their business processes and activities, decided to use a new IT infrastructure. It's exactly IS, and it's an IS project to improving and enhancing their IT infrastructure. Some cases about the database, some cases about networking, some cases about enterprise application. If you can, clearly understand the meaning of IS, you can understand the meaning of this case. And I suggest you to go Googling and find some information about this case and start reading. It may help you to, realize and understand its issue and challenges better and better. And based on that, you can, clearly understand it, why it's information system, why it's a managing information system case. Because management information system, we said when we have IT and use this IT in our organization, in our company, in our firm, to enhance our business processes and our business activity, we already make IS. So IT plus business is IS. Here you have IT infrastructure in a company for enhancing their productivity and their business activities. So it's exactly the IS. So if any one of you guys have a question, please do not hesitate to ask, or even during the week you can email me if something is not clear for you. If you have any kind of problem in your lecture, the slides, or your projects, you can email me. Don't worry. Please feel free to be in touch, or even through Facebook you can ask. Okay guys, and the other thing is please be noted that your presentation will start from week 8 and 9 for case study presentation, and from week 9 and 10 for your case study, and 11 and 12 for your e-commerce business plan. So don't forget to be ready by week 9 for your presentation. All the group should send me their slides in week 8, at least 2 to 3 days before our 9th session. All the 5 groups should send me their files. To be fair, all the groups should send the slides, their file for presentation, at least 2 days before the first presentation, before the week 9. Some of you may present on week 9, some may present on week 10, but all the slides should be sent 2 days before our week 9 session. Okay guys, it is clear?